Where are we? Okay, enter. When I click enter, I should have 50460. 50460, correct. Okay, so we determined the integral using substitution. We subtracted the area of the rectangle, and this is the consumer surplus. In other words, if we buy 899 units at $60 per unit, we get an extra value of $50,460. Now let's see how much they get extra, the producers. Okay, so I'm on page 6. Good. So the producer surplus is 53,940 minus the same integral from 0 to 899, but from the other function, from 2 the square root of x plus 1 dx. So this calculation will give us how much they get, the producers get extra, without giving us anything for it. They are giving us something, but they have their bonus, so to speak. Okay, so I'm going to start with this and then subtract from that. So the integral from 0 to 899, I'll put the 2 outside, and the square root of x plus 1 dx. In this case, what would you recommend? I don't recommend the square root, although it's not incorrect, but here I recommend something simple. So what would you recommend as u?
So it would be dx?
We are not talking about dx, we're talking about the function. So what should u be to simplify our x plus 1? And can anyone give us du? Without du, we cannot continue.
Would it just be 1?
1 times, we're looking at du, not f prime.
Dx.
Exactly. Good. So there is a 2 outside. The square root of u will be u to 1/2. Dx happens to be du. No adjustments are necessary. But now I need new limits of integration. When x is 0, how much is u?
1.
Perfect. When x is 899, how much is u?
900.
That's it. So 2, which function prime is u to 1/2? Which function prime is u to 1/2?
Would it be x plus 1?
You mean u to 1/2 plus 1 over 3/2. So the rule says we have to add 1 to the power, and whatever we get, we have to divide by it. So I flip, and this is 4/3. I plug in 900 to 3/2. Minus when I plug in 1 is the same thing. This is the square root of 900, which is 30. 30 raised to the 3rd power. So 4/3. 30 raised to the 3rd power minus 1. So what am I getting here? And then we'll check again. So 4 divided by 3 in parentheses 30 raised to power 3, and then minus 1. I got, just for the integral, 35998.667, and I could possibly change it into a fraction. Ugly one, but it's true. 107,996 divided by 3. Okay, so, but this is not our answer. The producer surplus equals 53940 minus this 35998.66. Whatever that is. Lazy people use calculators like me. Minus 35998.66. So I got 17941.34. We'll check it in a moment. So this is what they pocket without giving us anything. This is, if you want, this is their little bonus. Okay, so we calculate to make sure. So we have 53940 minus the definite integral from 0 to 899, and this is from 2, the square root of x plus 1. There is no need of parentheses in there in most calculators, but I like my parentheses. So when I hit enter, I have to get 17941.34. 17941.33. Oh, I didn't mean to do that. I meant to go to the book. Okay, so we are ready to look at a word problem now. You are not supposed to determine, we are not going into those details on, for example, these problems, only finding the equilibrium point and find a consumer surplus and producer surplus at the equilibrium point. These are topics, the dead weight loss and other situations that we do not cover in this class. We only cover the equilibrium point and the consumer surplus and producer surplus. So let's look at this one. Which page am I on? I'm on 7. Okay. Suppose the demand for bicycles in ocean shores, okay, is given by d of x, so that's 25. 275 minus 1.25x, and the supply function s of x, 135 plus 0.5x. And we know the drill. X is in thousands, and the functions are in dollars per bicycle. As we know, the y variable is in dollars per unit, and this x is in thousands. Okay, so these are in dollars per unit, and x is in thousands. Okay, so they want us to find the equilibrium point, the consumer surplus, and producer surplus. How do we start? How do we start? How do we find the the equilibrium point? Like before, there is no change. What do we need to do?
Set them equal to each other.
Perfect. Very simple. 275 minus 1.25x equals 135 plus 0.5x. Very simple situation. Let's say I move 135 to this side and I get 140, and I move 1.25 to the other side, and what do I get? 1.75. And I divide both sides by 1.75. How much did we get from 140 divided by 1.75? I got 80. Excellent. I have to determine the equilibrium point. This is good, but it's not good enough. How do I find the y coordinate?
Put in 80 to either
Exactly, doesn't matter. So I have 135 plus 0.5 times 80. I got 175. Correct me if I'm wrong. Please, always. Good. I have to find the area of the square, of rectangle. So that is 80 times 175, always. Once I have the equilibrium point, I multiply 80 in this case by 175, and the area is 14,000. Because I know this has to be subtracted from an integral, and then another integral is subtracted from it. Perfect. Can anyone give us the formulas for the consumer surplus and the producer surplus, and then we will work to determine them.
Would the consumer surplus be the indefinite interval between?
It has to be definite. Very good, but it has to be definite because it's a number. Yes, perfect. From
0 to 80.
Exactly. From which function?
75 minus 1.25.
275 minus 1.25x. Of course, dx minus this area. How do we determine the producer surplus? Yes?
Minus.
The definite integral, the same limits, but not from the same function. That's it. This will give us what we get a little bit of extra that we don't pay for it. And this gives us what they get extra without giving us anything for. A tiny bonus for themselves. We are getting something, they're getting something. In addition to what we pay for. Okay. For us, and they're getting some bonus without giving us anything for it. Okay, so the consumer surplus, 275x minus 1.25, x squared over 2. This function prime is this function prime is this, from 0 to 80, minus 14,000. Luckily for us, this is a polynomial. I only care to plug in 80 because when I plug in 0 is 0. So 275 times 80 minus 1.25 times 80 squared over 2 minus when I plug in 0, but that's 0, minus 14,000. Okay. Lazy, lazy, lazy. 275 times 80 minus 1.25 times 80 squared divided by 2 minus 14,000. Enter. 4,000. Looks a little excessive, but it's possible. In other words, if we buy 80 units at $175 per unit, we are getting a little bit extra that we did not pay for. We are getting some utility, some extra, 4,000. Let's check to make sure. So the integral from 0 to 80, and the function was 275 minus 1.25x, of course the x, and then minus 14,000. I click enter. If I don't get 4,000, I have to go back to the drawing board. Okay, so far so good. Moving on to the producer surplus. So producer surplus, 14,000 minus 135x, don't forget parentheses, plus 0.5x squared over 2, also from 0 to 80. So this is 14,000 minus 135 times 80 with minus in front, minus 0.5 times 80 squared over 2. We have to distribute the negative sign to both terms. Okay, ready? 14,000 minus 135 times 80. and minus 0.5 times 80 squared divided by 2. I got 1600. Checking. Okay, so this was 14,000 minus the definite, the indefinite, I'm sorry, the definite integral, of course. Okay, from 0 to 80. And the other function is 135 plus 0.5x. 135 plus 0.5x dx. When I hit enter, if I don't get 1600, I have to go back to the drawing board. 1600. How do we feel about consumer surplus and producer surplus? It's just a simple formula that we basically determine geometrically, so to speak. How do we feel about it? Is the formula okay? Do we understand it?
Yes. Yes.
Yes, ma'am.
Not too bad.
Okay, perfect. Not too bad, yes. And we remember how to determine it. So please remember, because it's always easy. Again, so this is one function, this is the other. Here is the rectangle. And always remember, it will always be easy once you understand. This is the producer surplus that we subtract from the area of the rectangle. So this is S of x. From the area of the rectangle, we subtract the area under S of x. And for the consumer surplus is this red area on top. So from the area under D of x, we subtract the area of the rectangle. Sorry about that. Okay, good. So now what I would like to continue with, I know we only have roughly 10 minutes, is the last section of chapter 5. We're not going to finish it. I just want to give a simple example. So this is called differential equations. So the first step here is we are going to be given a solution or solutions. We are going to be given the equation, that is the differential equation, and we will be asked to determine, to identify, to state whether the solution that we were given is indeed the solution